So let's talk about how to make an alcohol and an alkyl halide. And these are kind of related because they're a reversible reaction, and we're going to use the Shotle's principle to force them one way or the other. But in this case, let's start with alcohol. So in this case, we're going to start with butoxide and HCl. Now, the Cl is going to replace the OH minus. These are both Lewis bases. The question is, how do they do it? And this is the real problem with this methodology. It's also going to illustrate to you a lot of the reasons why it has the favorabilities it does. The first step in this mechanism is to protonate a hydroxide group. So when we protonate this hydroxide group, we end up with O, H, H plus, and Cl minus. Now this OH2 plus group is a very good leaving group. So what will happen is the OH2 group will come off. We'll get H2O, and we'll also get a carbocation. So this is going to proceed through a mechanism where we create a carbocation. Because of this, we can get rearrangements of the carbons. So this is going to be a major limitation of this methodology. It's also going to be why we favor more substitute carbons when we do this reaction. Now, with this plus group hanging out here, the chloride combined, because we go through a carbocation intermediate, this also means that we have the ability to, one, get rearrangement, but second, more importantly, if we do create a chiral center, we're going to create a racemic mixture. So your chloride is going to act like a base, and you're going to end up with this product. So this is the overall reaction. If we have an alcohol mixed with an acid like HCl, preferably a strong acid, we need something that can replace, so HCl or HBr or HI, we can get replacement of the hydroxide group to give us water. Reversibly, if we want to create an alcohol using an alkyl halide, add water, and what it'll do is it will drive this reaction backwards to give us the alcohol. But again, we can kind of see this issue if we go to something like a secondary or particularly a primary carbon. If we go through the reaction mechanism, we create a carbocation. We can get a carbon shift, and we can get replacement of the chloride with the new carbocation position to give us this compound. Now, because of this, this is not a reversible reaction. If we were to run the reaction reverse, most likely what we would get is this. So when using this technique, keep in mind that this is going to work best if you have tertiary alcohols or you want to make a tertiary alcohol. This is not the best thing to do if you're working with primary secondaries, and even then, because you're forming a carbocation in terms of practicality of actually running the reactions, you're far better work this with a tertiary alcohol or something that's going to either start with tertiary alcohol or form a tertiary alcohol instead of trying to do something that's secondary and definitely not for primaries.